what we are doing here, we are basically getting every single sample, and based on that single sample, one gradient, and we update, right? Whereas in practice, we usually like to have a sort of batch of samples, right? You get a batch of samples, you average the gradient over that, and then you update, right? So these are the things that we want to somehow address here. So this approach that we are right now doing is not very sample efficient, because we are basically using some samples. We take one sample, we update, we throw it away, we go for the next sample, and so on. We usually like to have a kind of batch of samples, so we go over it over and over and over, right? And this is a kind of thing missing here. And the other point is exactly the one that I told you. So the samples that we are collecting are strongly correlated, right? So what it means that if I have ST, right, and then I do one particular action, I go to another state, right? And then this state could be very close to my state, right? If you're thinking about a mountain car, this state is the location, right? This state, I do one action, I go up, right? And then that new state is very close to one. That's okay in terms of estimation, because the value of that state is reliable if the value I want to update. I'm going to start from this state and look at the next state, right? And the next state is very close to the previous state, right? So this is that you are going to tune your neural network to somehow match two different points to their label, which are very close to each other, right? So probably if you just forget about the second sample, nothing going to happen, right? Next gradient too much. So this is why I would say the samples are extremely correlated. So this is your first state, and so on, right? And they are very close to each other. So you are trying to fit your function into these points, right? But this function could get totally crazy out of these points, right? Totally irrelevant to the true function. Whereas if you want to really estimate, what should you do? If you really want to have a good label, good sample points to train your neural network, what is the best idea? What is the best kind of samples you can collect? Independent samples, right? The best idea is that you get some such sort of samples, right? Like every sample is happening randomly, and these, if you try to make your function somehow fit to this point, and this point, then hopefully if your function is smooth enough, it's globally fitting the true function, right? So you don't really want this case, you really want this case, right? And this is right against something missing. What we are doing, we are just looking in one state, we see what's the next state. We update here, then we go to the next state, right? Now we are in the next state, we again use the state after that to update this one, right? But updating this one is like you're just fixing the point right next to your previous point, right? You don't want that. You want rather this one, right? So I do update this state, then I randomly go to the state and see what is the next state of that one, then I update my Q function there, right? So this is what you want to do, and this is right now not encoded into our algorithm, right? So now, in order to get rid of these issues, so meaning that we can use whatever we had before, first of all, and secondly, to use them efficiently in the sense of correlation between the samples, the idea is to do something that we call it experience replay. And what is the idea? Just you get one database, right? Once you are just sampling the environment, make one database. And inside this database, whenever you are in one state and you do one action, you get the reward, you see what is the next state, right? You collect this one and put it as a sample inside that database, right? Then you go into the new state, right? Again, you do the one action, the next action. You're going to get an immediate reward. You see what is the state after that, yeah? Put it as another sample, right? So these are the samples of one trajectory, right? You go for the next trajectory, you update your neural network. What you would do, you just randomly sample from that database, right? So this means that once you just try to update your neural network looking at the first point in your first trajectory, another time you just use the middle point in your third trajectory to update, right? Once again, you go back to your first trajectory, another point, right? So you're randomly choosing states on these trajectories, and these states are now probably independent, right? Because you started here, you just moved, and then you got here, and when you're just randomly sampling, once you get this sample, right? So that is the main idea. You make one database, and in this database, you are going to save whatever you're collecting in your sampling, right? Now, you save them in the form of tuples, and these tuples basically tell you what is your current state, what did you get, what did you do as the action, what did you get as the immediate reward, and what was the next stage, right? And then you keep them as individual samples. Whenever you want to train, you just go and sample from that one independently, right? So it's like you randomly shake all of those tuples and start to use them, right? And this is going to give you some sort of independence. This is what we call it replay, because you have already all of those experiences you have seen on your trajectory, right? And you randomly choose one of them to replay it, right? And you have this benefit that you go over it over and over, right? Finish with all of those saved tuples. I again go back, right? I would like to see my very initial sample that I had. How does it look like with the trained version of my Q network, right? And I want to see whether I need to update or not, right? And I can go over it over and over. This is basically closer to what we are used to in deep learning, right? So, one key point here is that we can do this experience replay because basically we are playing off policy, right? Because every time that I want I don't care about the policy that I am playing, right? I'm only caring about my target policy, right? So each time, with deep Q networks, it gets, I think, is the most clear version of this off policy. Because with deep Q network, say you get your Q network and you go on with a bunch of samples and you train, right? If you get back to the sample that you started with, right? Now that you want estimate of the value for that sample, you don't really need to know the state to your neural network. You look at the output, you take the maximum one, right? You don't really care how you ended up with that state, right? So this is off policy, right? That is the key point, right? So you can get back there. Again, you see that, okay, in the next state, this network is telling me that the best value is this guy, right? So the greedy algorithm going to work like this. Now try whether my network is actually giving me the right value or not. Train my network further, right? Everybody's cool? Yes, but it's okay, right? Because your network is not estimating the value of your policy. It's estimating the value of the optimal policy, right? The greedy policy, right? And then what you say I was in this state, say my state was 1, and I went to state 2, right? Now, first, your network is not trained, so you have multiple samples. Each time that you go, you would say, this is my current state, this is my next state, right? You give the next state to the network, you see the outputs, you take the maximum value, you would say this is how the maximum Q value should look like, right? And then you try to train your network to give that value to you, right? Now, you again get back to the same sample, right? Last time, when you told you the initial state is 1, the next state is 2, right? Last time, when you gave state to your network, and you collected the maximum value, right? Once you collected that maximum value, and you added it to your immediate reward, you did not see the maximum value you would get in the state 1, right? You did not see it. And this was the reason that you kept on training, right? Because your label, what is your label? Is the immediate reward plus the maximum value in the next state, right? what is your value is the value in the current state, right? You wanted to see this. You didn't see this, right? So you kept on training. Now you get back, right? Now you are back. If that guy is properly trained, you should see it, right? You should see a better estimate, right? And you don't care that you collected this tuple using the another dummy policy, right? Because you don't really need any information about that policy to do this evaluation, right? So you are basically doing off policy. You don't care how you ended up at this point. You're always thinking about the optimal one, right? But because of that, you don't have any problem to get back again on the sample. You might tell me that, well, this is not a perfect sample, because if I really start from that point and play optimally, I would never end up here, right? But that's another story, right? That's like this particular state is not some state that I would normally end up when I'm playing optimal, right? But say I ended up, then I do know what is the optimal value, right? That's it, right? You get the idea? Okay. Yeah, so that is the idea of experience replay. And as I said, you need to be off policy. If you're not off policy, then basically your evaluation depends on the policy that you're playing with. Then this is not possible to do experience replay. And when we do off policy, basically we don't care about the policy that we're sampling with. This is the key point, that the off policy algorithms are more practical and are more sample efficient, because the same sample we collected with our dummy sample policy initially, we can reuse it again, right? Okay, now let's just look at this basic setup, that we have this data set and we also do the random sampling, basically the idea of experience replay, and see how it works in practice. So that was the vanilla version of deep learning, right? DeepQ learning. So we basically had it before. So we just do one action, right? And then when we act, we are going to go into the next state, right? In the very first version that I told you is not going to work, what did we do? We basically go on one complete trajectory. Compute a gradient and update your network. Now what you can do here, well, you can just do this, right? And then instead of going right away, like here is again vanilla version, but instead of doing this, you can randomly choose one other sample, right? This is the whole idea that we want to do. So this is why I'm going to write it down like this here. So what we are doing, we start with one maybe random policy or something. Then anytime we get into a state, we draw one action based on that policy. We see what is the next state, but when we want to update, just line 7, we don't care about the policy, right? We just play with the greedy, or think we are playing with the greedy policy. And then we get the sample for the greedy policy, and we update our Q network, right? Key points. What we are collecting is a sample for the or a kind of sample label for our greedy policy, right? And our Q network is basically trying to give us the value or action value of the greedy policy, right? So 2 things we should keep in mind. Everybody's cool about that, right? Okay, now that you have this, now we want to just do experience replay, right? So this guy would be the vanilla one. What is the vanilla one? You're in one particular state, right? This state, if you act, you are going to get one reward the next stage, right? Now, you can give your state as well into the neural network. This is your Q network, right? You are in one state. You give your state into your Q network. That guy goes inside the Q network. At the output of the Q network, all the action values. One question first. If you're doing Q learning, this network is estimating the Q value of what policy? So these values that you see at the output are values of which policy? The greedy one, right? The optimal one, right? So what you think You do know that this is yet not the optimal one, right? But you are just trying to make it give you the values of the optimal policy, right? So goes inside the neural network. At the output, you get the values of the optimal policy. Basically, the maximum values you can think of, right? Now, these guys come here, right? And now you need to somehow, I mean, this network is not trained yet, so you need to build a kind of label that you make this guy looking action AT. And I don't care what policy gave me this, right? I don't care about that. I just do action AT. Out of doing action AT, oh, sorry. Yeah, maybe I mentioned that one later. Maybe the order would be better this way. So after doing action AT, you are going to get your new state. You would say, okay, if I get into this new state, ST plus 1, and I give it to this network is supposedly telling me what is the optimal values for the new stage, right? If I take that one for granted, this means that if I take the value which is I would get if I play optimally, right? Right? So that is going to be the maximum of the output of your Q network in the next state among all the actions, right? Again, once you play AT, you get ST plus 1, RT plus 1, right? You would say that the next state is this particular state. Now, what is the optimal value for this state? Well, I give it into my Q network. That is going to give me, right? Because I do know it's not yet trained, but I assume, well, this is the target, right? I assume that this is giving me the optimal values, right? Now, if I want to play greedy, if I want to play optimally, what do? I'm going to do the action whose value is the most, right? So this means that I'm going to take the Q value, which is maximum, right? Everybody's cool, right? So this Q value plus the immediate reward that I get is one estimator of what I should have seen here, right? So if it was working fine, when I gave it ST, I should have seen that one, right? Everybody agrees? Yeah? So once again, okay, I hope that you get it because I spent lots of time making these animations last year. Hopefully it makes it more clear pseudocode, right? And I do understand it's too much of notation, it's too much of order, it's sometimes confusing, but I hope that at least the animation gives you the main idea. So once again, so let's start from here. I am in one particular state, right? And for this state, I assume that I am in one location, right? I assume that this network, if I tell it what is my state, is going to give me the optimal value, right? It means that this Q guy that I see is play action with the maximum value, right? This is your strategy in the optimal policy, right? So this means that if I do ST, right, and I get here, goes inside this one, at the output of this guy, I'm going to, right? And these values are the optimal values, right? Now, say that I just choose to do one action, and that I just check the maximum. I just do it with one random policy, right? I randomly decide to go this way, right? Now, if I randomly decide to go this way, and this network is working fine, right? The entry here in this network, which is proportional to that action I have done, should be exactly that number, right? Right? Should be the optimal value at the particular state that I was, action that I did, right? Everybody's cool? So I want my network to right now. So, well, say that I do this action. If I do this action, I'm going to get out of the environment the next state and the immediate reward, right? What does TD tell me? TD tells me that if you get immediate reward, add it up with the optimal value of the next stage, right? The optimal value of the next stage, right? This should be the optimal of your current stage, right? Everybody agrees? Right? So I use this to just build a label for my Q network. I would say that, okay, if I give this new state to my Q network, that Q network is going to give me one vector, and that vector is giving me the optimal Q values, right? Correct? No, if I want to keep on playing optimally, I should do the action whose value is the most, right? Correct? And I keep on always playing optimally after that. And this is the value that I'm going to collect ST plus 1 afterwards, right? Also, I do know what is my immediate reward, so I add it up to that one. This is the label that I want to see, right? I wanted to see this guy when I was at time ST, right? But I have not seen that. What should I do? I train my neural network to give me that value, right? Everybody agrees? Everybody sees what I'm saying? Right? Question? Once again, but if you want, you can ask once again. It's important. It's DQL learning. It's not a random algorithm. Everybody sees what we're doing, right? So when you are in one state, you evaluate your state, right? This is what you get out of your Q network. This is what you have right now. Then you are going to build a sort of label. And how you build that label, you basically play your action, you get your next state and reward, give your next state, see what is the optimal value for the next state, you add it up with your immediate reward. That should be exactly the thing that you were in, right? That is not. So what you're going to do, you're going to update, right? You're going to compute this delta. Also, you compute the gradient of your network at the particular state that you were, right? You're updating your value in the state ST, right? So your computation going to be here, right? Once you just went forward, then you go backward and compute the gradient, right? And then you use that gradient along with this delta to update your weight, right? Everybody's cool, yes? Questions? So this is vanilla DeepQ learning, right? The one which I told you is not going to work, right? In its very basic. Now, the only thing that I want to do in this is that once that I did this update, in the next time, I don't want to go ahead and start with ST plus 1, right? I want to go on one other stage, right? So what I do here, I am going to just build that database that I told you, right? So the thing that I do, like, let me see why I have this. Oh, yeah. So let me just skip this. Let me go on the diagram, and I get back to that slide. What I want to do here, I just want to update this state. Then I don't really like to update the next state. Right? And then updating this one would give me no benefit, right? Because already after updating this one, my neural network has somehow fit to that data such that this is going to roughly properly estimate the next one, right? So I want to just randomly go somewhere in time, get somewhere else that was not there, and I do the same strategy there. How can I do it? Well, I can start doing actions, right? So I just start playing with one policy, this environment, right? I do one action, I get the next state and reward, right? I again keep doing that. And each time I do that, I would just collect everything into one database. So I would say, okay, state, I did this action, I went to the next state, I get this reward. This is the first sample. Then I was here, I did another action, I got another immediate reward and got to a new state, right? I collect that one. Then I just did another action, and I got into a new state. I collected an immediate reward, and I keep on doing this, right? I just move get into the Now, I collected all of them. Each of them is going inside this database. But when I want to train my neural network, I do not start from very beginning going on, right? Randomly choose one of them, right? It's like I was here, I went here, I get this reward, right? Then randomly I jump here, right? Then I say, okay, I was here, I went there, I got that state, right? Then randomly I jump somewhere here, right? I was here, I went there, I got that reward, right? So this is what I'm going to do. I'm going to randomly sample from that database, right? Everybody's clear? So those samples, this is why I'm showing them by SB, AB, SB plus 1, RB plus 1, right? One of the, like, first time you sample, it might be your first sample. The next time you sample, it might be some sample after 100 time steps. Once again you sample, it could be the sample at time step 5, and so on, right? And these are independent, roughly speaking, right? So each time you do that, you are going to give this guy to your neural network, and you are going to do the same train. So what you are going to do, you would say, okay, SB is my current state. This guy goes here. I'm going to collect the value of this stage, right? The first one, which I'm going to keep here, right? Then I would say, okay, let's say that this network is trained. Then this means that if I give the next state, I should use TD and see exactly what I've seen for SB, right? So I'm going to give the next time step state. I collect the maximum value. I add it up to my immediate reward. I expect this one to look like this, right? If it's not like that, then I train, right? I do one step of gradient descent. So I update. I go for one random other state. I do the same thing. Everybody's clear? Questions? Yes. Oh, yes, yes. You have a bit of delay, right? But the point is that delay is sort of fixed delay, and after that, as long as I can build my database, so typically in practice what you do, you have a database with a specific size, right, a specific memory, and you fill it out, right? And then you start sampling from it. But each time you sample, right, in addition to updating your neural network, you also one action, right? And doing one action, you get a new sample, right? And you put that sample as a new sample. You just remove the old, and you keep on doing that. So it's going to be that is online, right? So that wouldn't be a problem. Yes? Yes. Okay. Yeah. Initially, you usually play randomly. You just fill out maybe halfway your buffer, and then you start updating, right? But the key point is that you should be able, one thing that you can do if you want to be 100% online, you can start doing vanilla Q-learning, right? Once you see your buffer is filled, then you just sample, right? You can do that as well. Questions? Yes? Oh, that one. No, you don't necessarily need that. So if you have a buffer, right? So what you typically do, you're going to do the rate of sampling, like tune the rate of sampling that you have with the batch size, so that every single sample is being used a couple of times and then thrown away. We typically do that. Because in practice, as I said, you keep on training, like randomly taking something from your data set, right? And then every time that you do one iteration, one sample update, then you also do act on the environment and collect a new sample. Okay? And you have this new sample, you add it to your buffer, right? And the oldest guy is going to go out. Okay? And you are going to somehow organize or tune the rate of sampling from the environment and the batch size that you use to train, so that once for example, your first sample is going out, you have already gone through it a couple of times. Or with high probability, you have gone through it 2 or 3 times. So this is a typical, I mean, theoretically, even if you just do it, like you keep the buffer increasing, right? And just each time you randomly take a batch and do that. That should be no problem as well, right? So that's in theory, but in practice, it could make you like, if you initially, it's like Q-learning. If you initially have started sampling with some very random policy, then when you keep it, you might get your model getting updated at some points, which are not that useful for you. Right? This could be the problem. Like it start to converge to a sort of parameters. Questions? No question? Okay, so now one thing, I mean, now we can get back to this slide. So in this slide, as I told you, so I hope that this is now clear. So what we mean by doing experience replay, every single time you're just building such a label for yourself, right? You're making this label. So you would say I am in this particular time st, right? Sorry, time t. I'm seeing the particular state st. And what I want to get is this label, right? Based on TD, I want to see at the output of my neural network the immediate reward plus the optimal value of the next stage, right? So that is the thing that I want to see. If it is not the case, I need to update, right? I need to gradient and update my parameters. Hopefully, next time it's closer, right? And since I'm computing the gradient, so it's just taking me towards a point where this difference is smaller, right? So that is going to be the case, and this is the idea of experience replay, right? Questions?